Hello, my name is Walker Owens, and in today's presentation, I'm going to be explaining to you all the different computer parts and how they work together. So, in my introduction, I believe people don't think about it too much. To be completely honest, whenever they buy a computer, they just hook up the keyboard and mouse and they just start using it. They never think about why the computer works or how it works or how they're able to do what they do. Computers run almost everything we do on a daily basis. Um, any future, for the future reference, we're growing computers every single day. Computers just get better and better, and it's important for us to understand why they get better and how to improve to make them faster, stronger, and just more compatible with us. They rely on they rely on multiple different parts to all work together. Um, as I'll explain today, they um, work together to create an entire system where we can do basically anything. Today, I'll explain key computer components, their functions, and how they interact as a system. So the core components of a computer are the CPU, which processes instructions, the RAM, which is the temporary working memory, the storage, the SSD, and the HDD. Long term, which holds the long term data. The motherboard, which is basically the heart of the system, it connects all the parts together. The GPU, it handles the graphics. So think about like a screen whenever you're watching a movie, like on a TV or something. And the power supply, which it just delivers electricity to the entire system. So first, the processing and memory. So the CPU, it's also known as the central processing unit, executes instructions from programs. So basically, it gives instructions to programs, um, and it basically takes that information to be able to run the application a little better, maybe a little faster, and it performs calculations and logic. So basically, think of the math problem as of the computer system. The RAM actually helps the CPU. Um, RAM is what the RAM takes data or information from the memory, take, gives it to the CPU to run more efficiently. The key idea for this is the RAM feeds the CPU data so it can work efficiently. Storage and data flow. So storage, which is the SSD and the HDD, stores operating systems, applications, and files. The SSD it's faster. It has no moving parts, so it stays stationary. And the HDD is slower, but it has spin disks inside of it. Um, data flow process. So basically, data moves from the storage to the RAM to the CPU. So the RAM pulls data from the storage and gives it to the CPU to work more efficiently. The CPU can't process any data directly from the storage. It has to move through the RAM to get it. Why it matters? It's faster. It loads applications a lot faster if it goes through the RAM. Um, More RAM, which is smoother multitasking. So if you have multiple applications open at once, the RAM will be able to help it um, uh, use all of those applications and keep them open without the system crashing. And slow data can also cause a lot of lag for your computer. So if you have a lot of applications open and your computer can't handle all of that information at once, your computer's just going to lag and eventually fail, and the whole system will drop. So the more RAM you have will give the more data you have will also equal out the more RAM you have, which will help the CPU be able to load all the other information for the applications. The connection and output. So the motherboard, like I said before, is basically the heart of the system. It's the main circuit board connecting all of the components. So like your GPU and your power supply are all connected to the same device in the system. It allows communication between parts. The GPU, also known as the graphics processing unit, which can also be called a graphics card, it renders images, videos, and animations. Um, it basically think about your TV. Your TV also has a graphics card. Anything with a visual output has a graphics card, so it can um, give you clear images. Um, it also works with the CPU. The power supply, it just converts electricity into power for all components. Without the power supply, the computer's not going to run. It's not going to even going to turn on. How everything works together. So a good example of testing how if the computer works properly is opening a game or an application. So the storage sends data, the RAM collects that data, it loads the active files, gives it to the CPU. The CPU processes that information, and the GPU displays all the visuals. So like a video game or like a video, it'll display it on the screen for you to enjoy. It happens in milliseconds. It's extremely fast. They all work together in rapid speed to get the information to your screen. And all parts must work together for good performance. If one component of the computer doesn't work, none of it will work. Your entire system will fail. Why it matters. It helps to troubleshoot computer problems. Um, Running an application will be able to tell you what problems you may have. If a game won't run, you can run a diagnosis and it'll tell you what the exact problem is. Um, it improves understanding of everyday technology. Being able to understand how a computer works will help us better future technology for the better of humanity, and useful for careers in tech, gaming, and engineering. Much like myself, I'm going to be indulging in the um, career of computer engineering, and being able to understand how the system works will not only make me better for future projects, but it'll also make um, others better to make better technology for humans to use better operating systems. In conclusion, computers rely on multiple different components. Each part has a specific role, and together they form a fast and efficient system. And thank you for watching my presentation. Have a good day.